Hello students, welcome to Aditya Academy. I'm Dr. Ragini Arora, and now in this video we are going to solve question number 9 to question 16 from exercise 14.5. The chapter is probability. Now this question says a box contains 5 red marbles and 8 white marbles and 4 green marbles, right? So red are 5 and white are 8 and green are 4, right? So we have 3 different colored marbles in a box. So the total number of marbles is 5 added to 8 is 13, added to 4 is 17. Now he says one marble is taken out of the box at random. What is the probability that the marble taken out will be a red marble? So we have to find the probability of a red marble. So these are not equally likely possible outcomes since we have different numbers of marbles in this box. Probability of red marble. So this means number of favorable outcomes upon total number of outcomes, right? Total outcomes. So what are the favorable chances for red? How many red marbles we have? It is 5. 5, and if we have to draw red marble, that means our focus is on red marbles. So favorable outcomes are red marbles, which are 5 in number, and total outcomes, total number of marbles in the box are 17. So the probability of getting a red marble is, this is the answer to the first part of this question. Probability of a red marble becomes 5 by 17. Now, the second part says, what is the probability of getting a white marble? Probability of getting a white marble. So here we have to keep number of favorable outcomes. That is number of white marbles at the top. That is, we have 8 white marbles and total are 17. So the probability of white marbles becomes 8 by 17. The third part is not green. Probability of a marble being not green. That means this is a kind of complementary event. So to find this, first we can find the value. Either we can directly put the value like total outcomes minus green marbles, that is favorable outcomes, upon total outcomes, right? So the formula says total outcomes minus favorable outcomes divided by total outcomes. That is, total outcomes are total number of marbles here is 17. Green marbles are 4 in number. So 17 minus 4 by 17. That is 13 by 17 is the value of, or the probability of drawing a marble which is not green, right? Or we can also calculate it this way, as we had, see, we have already found the values of probability of red marble and white marble. Probability of green marble is, how many green marbles do we have? We have 4 green marbles. So probability of green marble becomes 4 by 17. And the probability of not green is the complementary event. So we get 1 minus 4 by 17. That is 13 by 17. So these are the two ways. This is one way and this is the second way. You can find the value of not green or any complementary event by either of these two methods, right? Next question says a piggy bank contains 100 50 paisa coins. So I'm writing here 50 paisa coins are 100 in number. Then 50 1 rupee coins. 1 rupee coins are 50 in count. 20 2 rupee coins. So 2 rupee coins are 20 in count. 10 5 rupee coins. 5 rupee coins are 10 in count. So they are 10 in count. So this is the count of different kind of coins in a piggy bank. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin, okay, now that piggy bank is just open and one of the coin is fallen down when we turn that piggy bank upside down. Let's say one coin has fallen out of it. What is the probability of the coin being a 50 paisa coin, right? So probability of 50 paisa coin. First of all, we need to add all the coins. The total number of coins in the piggy bank is 100 plus 50 plus 20. This is 150 and 20, 70, 170 and 10. We have 10 5 rupee coins. So we add up to, all these add up to 170 and 180. So now this is 50 paisa coin. We have to find the probability of 50 paisa coins. So we keep number of 50 paisa coins at the top in the numerator, number of 50 paisa coins, and total number of coins in the denominator, right? Total number of coins. So the chances of falling off a 50 paisa coin is 100 divided by 180. So we have 10 by 18 or 5 by 9. And next part says will not be a 5 rupee coin. So this is also a complementary event. For that I am first calculating the probability of 5 rupee coin, right? So probability of 5 rupee coin is what? The coin being a coin of 5 rupee denomination is number of favorable outcomes for 5 rupees, which is 10, and total number of coins is 180. So the probability of falling off a 5 rupee coin from that piggy bank is 1 by 18, and the complementary event for that, not 5 rupee coin, is 1 minus 1 by 18. We can write the formula here. Probability of 5 rupee coin plus probability of not 5 rupee coin is equal to 1. So I'm subtracting the probability of 5 rupee coin from 1, that is 17 by 18, right? Or you can also consider it this way, that we have to take total outcomes minus favorable outcomes for being 5 rupee coin upon total outcomes. Total outcomes are 180 here. Favorable outcomes for the coin being a 5 rupee coin is 10. And here also we have total. So this is 170 by 180, which is also 17 by 18. So you can use any of the methods, right? Next question is, Gopi buys a fish from shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish. Now male fish are 5 in number and female fish are 8 in number. What is the probability that the fish taken out is a male fish? This is simple. Probability of that fish being a male is number of favorable outcomes upon total number of outcomes. Total outcomes. Well, favorable here are total number of male fish is 5 and total outcomes are, total you can write here first, 8 plus 5 is 13. So we have 5 by 13, the probability of getting a male fish. Okay, now the next question is around this running wheel. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers from 1 to 8, and these are equally likely outcomes. right? So that means the area divided on this picture, this is made on a circle, and the circle has been divided into 8 equal parts. All the parts are equal here, so occurrence of any number is equally likely possible here, right? So now he is asking what is the probability that it will point at 8. So the sample space for this experiment becomes these 8 outcomes which are equally likely possible, right? So since all of the outcomes are equally likely possible, so the probability of every event is same. Every elementary event has a probability of 1 by 8 here, because they have been allotted the same portion on a circle, 8 equal portions. So here you have favorable outcomes upon total outcomes. For 8 we have only particular outcome 8, which is 1, and total outcomes we have 8. So the probability of the arrow being stopped at 8 is 1 by 8. Next is an odd number. So out of these 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers, out of which 4 are even and 4 are odd. So since we are looking for odd numbers, these are the 4 favorable outcomes. Probability of an odd number. So this is number of favorable outcomes upon total outcomes. Here we have 4 favorable outcomes out of total 8. The probability of getting an odd number, or the arrow being stopping at an odd number, is 1 by 2. Next we have a number greater than 2. 1, 2, 3, 4, 6, 7, 8. So we have 8 possible outcomes and we require a number greater than 2. How many numbers are greater than 2? So we cannot include 2 here. 1, 2, 3, 4, 5, 6. Probability of number greater than 2 is number of favorable outcomes upon total outcomes. Favorable outcomes are 6 in count and total outcomes are 8. So we have 3 by 4 as the probability of getting a number greater than 2 on the pointer of the arrow, right? Next is a number less than 9. Okay, now you can see that in the sample space of this event, this experiment, these are the possible outcomes. As you can see in the sample space, all the numbers are less than 9. So here probability of number less than 9. So the favorable outcomes upon total outcomes. How many favorable outcomes do we have? We have all the 8 possible outcomes are favorable here because all of them are less than 9. And also the total number of outcomes is also 8. So this is a certain event, certain or sure event, because the probability of this event, elementary event, is 100% or it's 1. Next question says a die is thrown once, right? So I'm writing the sample space for a dice, which is 1, 2, 3, 4, 5 and 6. So the question says what is the probability of getting a prime number? So here we have to write favorable outcomes, total number of favorable outcomes, and denominator we have total outcomes. So how many favorable outcomes are there? For prime number, how many prime numbers are there? Prime numbers. Prime numbers are 1 is never prime. Generally children make mistake while doing this question. Prime 1 is not a prime number. 1 is a unique number. We never consider 1 into prime or composite, any of these classes. 1 is a unique number, so please keep it aside. You can treat this number is an odd number. It's okay, but this is not a prime number. The first prime number is 2. Then 3 is also prime and 5 is also prime. So we have 3 prime numbers. Please mark this question very important, because this is a very common mistake which is made by even good students, that they consider 1 as a prime number, which is wrong. 1 is a unique number, that is not prime. So here, out of these 6 numbers, 2, 3 and 5 are 3 prime numbers. So favorable outcomes are 3 and total outcomes are 6. So the probability of getting a prime number on the throw of a dice is 1/2. Second is a number lying between 2 and 6. So 1, 2, 3, 4, 5 and 6. Probability of getting a number between 2 and 6. Between 2 and 6 means, when they say between, that means this 2 and 6 are not included. So we have 3, 4 and 5 as 3 favorable outcomes, right? Consider this, when we are talking between, when we want numbers between two numbers, these are the boundary elements. They are not included in this. Between means we have to look for the numbers which lie between 2 and 6. So probability of 2 and 6. The first of all, I am writing the favorable elements, which are 3, 4 and 5. So probability of number between 2 and 6, this is number of favorable outcomes upon total outcomes. So that is, we have 3 favorable outcomes and 6 total outcomes. So the probability becomes 1/2. Right? Next is an odd number. Sample space of a dice is this. So how many odd numbers are there? 1, 3 and 5 are odd. 1, 3 and 5 are the set of 1, 3, 5 is a set of odd numbers from this sample space. So the probability of an odd number is number of favorable outcomes, and this is total number of outcomes. That means favorable are 3, total are 6. So this is 1/2 probability of an odd number. Right? Next question is, now this question is about deck of cards. Now since I have already discussed all kinds of cards in the introductory video, I am trying to do it again in short, but if you get confused, you can just go back to that introductory video and just learn all the types of cards in all the terms like colors, suits and face cards. We have 52 cards in all. According to color, we can divide those 52 cards into red and black, right? Black are 26 in number and red are 26 in number. And then we have 2 suits in red and 2 suits in black. Red suits are diamonds, which are 13 in number, and hearts, which are 13 in number, right? And we talk about half of the cards are black. So the 2 suits in black color are clubs. Clubs are 13 in number and spades are 13 in number, right? And these 13 numbers are from 1 to 10. They are cards, numbered cards, like 1 is ace and 2 to 10 are numbered cards. And after that we have J, Q, K in all the 4 suits. So these J, Q, K are called face cards. We have 3 face cards in one suit. So 3 and we have 4 suits. 3 face cards in one suit. J, Q, K are 3 face cards in one suit, and we have 4 suits. So we have 12 face cards in all. Right? So now this was a short description of type of cards in the pack of card. Now we come to our question. Like probability of getting a red king of red color. A red king. Right? Now come to red color first. We have half of the cards are red and half of the cards are black. And further, red cards have 2 different suits, diamonds and hearts. I told you every suit has got 1 to 10 numbered cards. Then every suit has got 3 face cards, which has 1 jack, 1 queen and 1 king. So we are looking for kings. 1 red king is here in diamonds and 1 red king is here in hearts. So if we talk about red kings, number of favorable outcomes. How many red kings do we have? Those are favorable. And total number of cards. Total outcomes are in the denominator. So number of favorable outcomes, we have 1 red king here in diamonds and 1 red king here in hearts. So we have 2 red colored kings. We are looking for red colored king. We have 2 in count and total cards are 52. So the probability becomes 1 on 26. Right? Next question is a face card. As I told you, we have J, Q and K. J stands for Jack. Q stands for Queen. And K stands for King. Every suit has got these 3 face cards. Right? These are face cards in one suit. These are one suit and we have 4 suits. 3 face cards in one and 4 suits. So we have 12 face cards. So probability of getting a face card. So the favorable outcomes, number of favorable outcomes upon total number of outcomes. Right? They are number of favorable outcomes here. Total we have 12 face cards. And total number of cards is 52. So divide this 4 3s are and 4 13s are. So there is 3 by 13 is the probability of getting a face card. Next we have a red face card. See, we are drawing only one card from the pack of cards. So red face card. Now since the cards are 52, then red cards are 26 and 26 are black. Right? 26 are black. Now red are 13 diamonds and 13 hearts. Now he's asking for a red face card. Here we have J, Q, K, which are 3 in red in color. Here also in hearts we have J, Q, K, which are 3. Right? 3 diamonds are red colored and 3 hearts are red colored face cards. So in all we have 6 red face cards. Right? So the probability of getting a red face card. A card should be red as well as a face card. So we have 6 such cards which are red in color as well as they are face cards. Total number of cards is 52. So this is 3 over 26. Right? The probability of a red face card is 3 by 26. Yes, now is Jack of Hearts. Like I told you, total are 52 cards. Then we go down 26 red and 26 black. Right? Now red are diamonds and hearts. Diamonds and hearts. Right? Black are clubs and spades. Now he is asking the probability of Jack of hearts. See, hearts are 13 in number and they have 1 to 10 numbered cards, then Jack and Queen and King. You can see this, there is a unique card which is Jack in hearts. First we went down to red cards and black cards, then we went to two suits in red cards, then it came to a particular card which is Jack of hearts. Hearts is a particular suit. There are 13 cards in it and Jack is a unique card of this particular suit. So the probability of Jack of hearts, right? So this is number of favorable outcomes upon total outcomes. Total outcomes. Favorable outcome is exactly 1 because now he is asking about a particular card or particular suit. It's 1 on 52. Right? Next we have a spade. So to just go back to this. This is, there are 4 suits: diamonds, hearts, clubs and spades. So spades are 13 in count. This is a suit. We have 13 cards which are spades. So when we talk about a spade, probability of drawing a spade, we write number of favorable outcomes. And then we have total outcomes. Favorable outcomes, here we are looking for spade cards and we have favorable 13 spade cards and total cards are 52. So the probability of drawing a spade card is 1 by 4. Next is the Queen of Diamonds. Here also if we go back, see, diamonds is a particular suit. In this also we have 1 to 10 numbered cards, J, Q and K. Queen of Diamonds is a particular card which has a particular suit and a particular number. So this is exactly 1 card. Probability of Queen of Diamonds. So this is number of favorable outcomes upon total outcomes. Favorable is exactly 1 and total number of cards is 52. Probability of drawing a Queen of Diamonds, since it is a particular card, so it's 1 by 52. Right? So these were the card questions. Now this is another question. 5 cards, the 10, Jack, Queen, King and Ace of Diamonds are well shuffled with their face downwards. Right? So one card if then picked up at random. So now here we have only 5 cards. 10, Jack, Queen, King and Ace of Diamonds. 10, Jack, Queen, King and Ace of Diamonds. Right? These are 5 different numbered cards. These J, Q, K are 3 face cards and 10 and Ace are 2 numbered cards of a particular suit which is diamonds. These are the 5 cards. Now one card is picked out of these 5 cards. They are shuffled first and then one card is drawn out of it. So what is the probability that the card is the Queen? Now see, probability of Queen is number of favorable outcomes. Here you have only 5 cards. Don't forget, don't take the total number of cards as 52. The sample space has got only 5 cards which are given in the question. They are 10, Jack, Queen, King and Ace of Diamonds. So we have these 5 total number of outcomes. Total outcomes. Here is asking the probability of number of favorable outcomes. How many queens are there? What is the probability that the card is queen? How many queens are there? We have only 1 queen here. So number of favorable outcomes is 1. And total outcomes is, we have 5 cards in all. The probability of drawing a queen out of those 5 cards is 1 by 5. Next, if the queen is drawn and put aside, See, in the previous first part, the sample space had 10, Jack, Queen, King, and Ace. Now he says the Queen has been taken out and it is not replaced into those 5 cards. Now, that means we are now having 4 cards in our sample space: 10, Jack, King, and Ace. The Queen was taken out and it has been removed from that pack of cards. So, sorry, those 5 cards. Now, if the Queen is drawn and put aside, what is the probability that the second card picked up is an Ace? So, the probability of drawing Ace is what? Number of favorable outcomes upon total number of outcomes. So now we are left with these 4 cards. These 4 cards have got only one ace. So favorable outcome is only 1. And in this case, now the total number of cards has been reduced to 4. Because the card which was drawn earlier, it has been kept aside. It has not been replaced into that set of cards. So the probability of drawing an ace becomes 1 by 4 now. The next part says, if the queen has been replaced, queen has been put aside. So now again he is asking the probability of drawing a card which is queen. So when we talk about favorable outcomes, now this is the sample space after queen has been put aside. So there is no other queen left in those outcomes. So favorable outcomes is 0 and total outcomes is still 4. Probability of drawing a queen from these remaining 4 cards is 0. Next is, we have 12 defective pens are accidentally mixed with 132 good ones. So the number of good pens is 132 and defective pens is 12. So now the total number of pens becomes 132 and 12 is 144. It is not possible to just look at a pen and tell whether it is defective or not. One pen is taken out at random from this lot. Determine the probability that the pen taken one is a good one. Now the whole lot of the pen is 144, out of which 132 are good ones and the 12 are defective ones. If one pen is drawn out randomly, what is the probability that pen is taken out good? So we have to write number of favorable outcomes upon total outcomes. So here the good ones are, how many are they in count? 132. Good ones are 132 in count and total are 144 in count. Probability of drawing good pen becomes, so this is 4 3s are 12 and 4 3s are 12. 4 3s are 12 and 4 6 are 24. So this is 11 by 12. So the chances of selecting a good pen out of a lot of 144 pens becomes 11 by 12 in this case. Right? So these were the questions from question number 9 to 16 from exercise 14.1 from NCERT. I hope these questions are clear to you. In the next video, we will cover all the rest of the questions from this exercise. I hope you liked watching this video. Please subscribe, like and share it with your friends. Thank you.